The broadcast is now starting. All attendees are in listen-only mode.
Good evening, good morning, good afternoon, depending on the time that you're in. This is Frank with the vBrownBag crew, and today I am joined by, I hope I don't mispronounce this now, by RI, and who's going to give us a short introduction and overview over MCollective. Just a bit of housekeeping, as always. If you have any questions during the session, feel free to either use this chat or raise your hand, and we'll get back to you. I'll also be monitoring Twitter on the vBrownBag hashtag. And we do run those shows on a quite regular basis. We're always looking for presenters as well. So if you do have a topic that you would like to present before starting out at a VMAC or public speaking, for example, feel free to get in touch with the vBrownBag crew or with myself on Twitter, and we'll see that we can set things up with you. And with that, I'll hand it over to our guest of honor today.
Okay, hello. I'm not sure which screen you're seeing, to be honest. I can't see my own screen.
I'm seeing a ping terminal now.
Okay, good. That's handy. So that'll help me. Give me 1 second. And that's probably the wrong side then. Hold on.
That is the presenter mode, yes.
I wonder how to flip that.
Is this PowerPoint or is it?
There we go. I think that should do it.
Yeah, that looks good.
Good. Okay. Sorry about that. Okay, so first of all, thank you very much for having me. I appreciate the invite. It's been a few months since we set it up, but I'm very glad to be here. So I'm going to have a quick talk about MCollective. MCollective is a tool I developed a few years ago, well, like a decade ago. As a quick introduction, I'm an independent consultant. I do work for all kinds of government and finance and startups, and I've done pretty much the whole gauntlet of everyone except maybe banks, luckily. I've been involved in automation and DevOps and that kind of stuff for a very long time. DevOps, I was in the first DevOps day, so been there for ages. If you're part of the Puppet community, you may recognize me. I've developed quite a few pieces there, Hera, MCollective, Choria, etc. So a quick overview then of MCollective. MCollective is an orchestration tool to assist with managing of your servers. It shines at really large scale, thousands, tens of thousands of machines. It covers the space for ad hoc automation, so where Puppet ensures that your machines meet the ever managed baseline. MCollective is a tool that allows you to do ad hoc commands, upgrade this package, roll out that software, do this upgrade, these kind of things. It integrates with many kinds of data sources to find out the which nodes you have and their names and what their metadata is and how you can discover them. It has a very strong focus on authentication, authorization, and auditing. So it has a very good fit in enterprises where perhaps some other tools are more kind of a square peg in a round hole. It's a Ruby tool, so it is extensively using Ruby, and it uses middleware for its communication rather than something like SSH. And it's quite old now. It's a tool that I wrote initially, but I've sold it to Puppet. I think it was like 2009 or so. And I'm going to show you, how it works, what it does, and maybe a bit of a demo of it. And I will talk about a sister project that I've started now about a year and a half, 2 years ago, called Choria. Choria is a set of tools and plugins and end user features built on top of MCollective. It lets you do a very easy installation path. Previously, MCollective was effectively impossible to install. Now you can go in 20 minutes, you can be production ready if you're a Puppet user. I've tested it to well over 100,000 nodes, no problems, and it's very tightly integrated into the Puppet ecosystem. So Choria improves the networking for MCollective significantly, and it's an independent open source project. Links to all of this will be at the end of the presentation. So MCollective, it's a CLI tool. Primarily, it's used on the CLI for ad hoc orchestration. So you would type things like MCO service restart, which restarts a service, or MCO packet install, or MCO package upgrade, and you'll see something along these lines. And what you're looking at here is basically we're invoking an API called service. We're asking it to restart a certain thing. That API takes inputs, of course. Which service do you wish to restart? And it discovers based on metadata about your machine. So rather than having to know your host names, or having to have all of these thousands of names in your head and be able to decipher things like host naming conventions and so forth, or dynamically generated names, it focuses on metadata. So here I have metadata that says in which country a machine is and in which customer the machine belongs to. And using that metadata, you address your machines, and it will only affect those machines. So it then discovers the machine. Yes.
So where would that metadata be stored then?
So in this instance, well, in Puppet context, you would either store that data in PuppetDB. So PuppetDB is like a CMDB of all of your known things to Puppet. So that's one place. The other option is that there's no storage at all. It will communicate with the network, and it will discover dynamically what is currently able to be administrated. So it's a difference between, let's say you want to update something now, to best efforts, all the machines that's up, they should get this right away. You choose the dynamic discovery method. But if you wish to upgrade your web tier, for instance, you need to know which machines are there. You need to be sure which ones are not answering or which ones are down. And so you can switch over to PuppetDB for discovery. So you have those different kind of contexts, but it's pluggable, so you can discover against a whole long list of features or sources really. It then shows you a list of the progress bar will shows you as those machines are responding. By default, it shows you only failure outputs. So the idea is that if you're restarting a web server on 1,000 nodes or 10,000 nodes, you don't care for the 9,999 OKs. You only wish to know which one of those failed. And so the RPC system has a strong knowledge of success and failure, and it understands within the context of a service restart, you only want to see things that failed. But at the end, to help you a little bit, that it's not like just confusing, it gives you a summary of what those things are. Now you can adjust these things, and maybe when you do a service status, it will understand while you are asking for status, it should probably show you the status, and it will then show you all the output. So the user interface dynamically show you context-aware summaries of what's going on, to really let you hone in on just what you need to know at a specific time. And underneath is a API. So here I'm typing into a raw Ruby REPL, and I'm doing the normal stuff. I'm doing normal Ruby code, but I'm doing exactly the stuff I just did in the CLI. So I'm doing discovery, I'm finding out my nodes, I'm turning off the progress bar, and I'm printing the status of my nodes. And you can see the data at the back there. It's it's normal data underneath. It's not like strings and strings of shell output, which will be different between different operating systems and so forth. It gives you data that you can work with. The underlying infrastructure is very introspectable. So these web interfaces you're looking at here, where it says service agent, start and stop system services, and there it asks for a service name, and it gives you some help underneath what kind of status you want, and it understands that the one input is a string, and it understands that one input is Boolean. And on the output side, it understands the difference between, just like a data structure called sender and the nice, friendly English word that says service status. And so this is all baked into the underlying services. And so the user interface that you see here on this web page is completely dynamically generated. There is no hard coding whatsoever. It didn't know, well, it doesn't know what you're doing. It just presents the services in a user-friendly manner for you. And so if you were to develop your own deployment tools, for instance, on top of MCollective, you will get these kind of user interfaces effectively for free. So that's kind of the space that it is in. It's in this kind of dynamic stuff. It's quick. It's really nice to use on the user interface. I'll show it to you in a little bit. And that's the kind of things that we do with it. Architecturally, as I mentioned, it communicates over a middleware. So in the most basic of deployments, you have a middleware component, and in Choria I use NATS, which is it's a very fast, very lightweight middleware, easy to deploy. You then have all of your nodes you wish to manage. They communicate with the middleware, and you have the place where you type in your commands, which in MCollective terminology is the client, NATS and the servers. So at no point does the client send a packet directly to any node. There's no SSH connectivity. You don't need to be able to route to the nodes. You only need to route and have firewall rules to the middleware. And the middleware doesn't connect to anything. Everyone connects to the middleware. So there's no incoming open sockets on any of these machines, which is a very important property within enterprise deployments. Now, this is the most basic deployment. And with Choria, this will take you to 50,000 nodes, no problem. Out of the box, you'll be able to do this with 50,000 nodes. I've done it with 300,000 nodes. It worked. So even this most basic thing is extremely scalable. But as you start growing and as you span the globe, you can grow very large. And the overhead of managing a large global middleware network is quite prohibitive. It's very difficult to do that. And so what Choria specifically allows is, in this picture, we have London, Tokyo, and New York. Those are completely isolated sites. You don't have to worry about how does New York and Tokyo communicate, or how does London and Tokyo communicate, or how does this central point communicate on the middleware layer. You just have to worry about deploying one middleware in that site, and it's isolated. There is another piece of software that comes as part of Choria that will federate all of these networks into a central management network. Now, this might not, you don't, maybe you want to do this where you have isolated DMZs. And if you build it in this manner, New York cannot communicate with London or Tokyo directly. Like, it's not possible. Only the administrator can communicate with all of the sites. So if one of these was a DMZ, that would be a secure way to isolate those machines while remaining administrable. Additionally, if you have an outage and London becomes isolated, but you have administrators maybe in Europe, and they can access the London site via SSH, let's say, they can then run those same MCO commands, and they can target those same machines in London, but then it will be isolated only in London. So these units are fully functional, fully standalone, but they're federated into one system, and they share authentication, authorization, and auditing. So I'm going to do a quick demo about this stuff, and you'll see it in action, and you'll see the kind of performance you can expect from it. And then I'll talk a little bit more about Choria and what does the roadmap for the stuff. Give me a second. Let me switch over here. If there's any questions, please feel free to send those over. So long. Okay.
That's looking good. Now even I can see it.
So what you're looking at is it's a EC2 shell. In this instance, I don't have any metadata database. There's no, at this point, I have no idea what there is. But if I type mco ping, it will immediately communicate with all known machines. If they're on the middleware and addressable, it will find them. Well, let me just do that again. I can look at one of these machines, and I can see some information about it, its version and when it started up and so forth. I can see that it provides things like Puppet management, package management, service management, file management, etc. And there's some other, this is a Puppet managed machine. So these are all of the classes that's on those machines. These are Puppet classification classes and Puppet set of code. And then Puppet, of course, delivers a whole bunch of facts about the machine. So these are information about the machines, what operating system they run and so forth. So let's look at something over here. I don't know. What would be unique to the machine? Oh, it doesn't really matter. Let's say, let's do this. So if I do encode find with Puppet, no, that's not specific enough. Let me see, give me a second. So there's a specific role deployed onto this machine. In Puppet language, this is called roles and profiles, which is the way for you to classify machines. So I can say, well, first of all, find me all of my machines that are classified as emulator. Now, and that's it. I don't need to know these host names, but what I could, for instance, do is find out when last did Puppet run on all of the machines tagged as emulator. I'm scrolled a little bit, but you can see it shows me the 16 machines. They're all idle. They've all deployed, run Puppet runs quite recently. None of them are currently applying. You get some summary about your information because, imagine you've done this for 1,000 machines. You'll have some summary, and you can then go and scroll around. I can do things like run them all, and batches all 5, 20 seconds apart. And there it goes, and it's kicking them off, and they will start their runs staggered 20 seconds apart. I'm just going to pause this because there's no really point in demoing that just there. But if we go back now and we do the status again, some of them are probably, Puppet has a feature, oh no, they're done actually, they were very quick. You can see there they ran, and I kicked off 5, and 5 of them recently run. Well, another one, they run every half an hour, so maybe we just bad luck for timing. So that's quite nice, and we can do things like package, status, Puppet agent, and it tells me across the entire estate what the package is, and again, nice summaries here. Now, of course, I'm asking it for status here, so it's going to tell me the status. But I could do things like service restart SSHD, and this is where the demo can go really bad, but let's see. And it's done it. And yeah, because the thing I'm doing is make a change, it's only going to show me the stuff that's changed. There's no reason to show me, all of the changed machines and every change that was actually done. It knows whether it passed or failed. And so that's how the CLI is. It's fairly quick. It's I can do things like, let's have another look at this machine here. Well, these machines are all the same. Okay, actually, let's have a look at this. Role emulator, enter fact role. And it will do me a nice report of the different roles that I have in my infrastructure, and I can go find me all the Puppet masters, and there they are. And then, I can do things like service status, Puppet server, on all my Puppet masters. Of course, there's only one, so it's not super exciting, but you get the idea that I don't need to understand the host names or where these machines are. I can think about higher level abstractions. And if I'm in a company setting or an enterprise setting, we would have our own vocabulary within our teams. We would call our database machines, maybe we call them DBs, or we call our web tiers Web1, or we call them App Server 1, or whatever terminology we have within our company. If you make that metadata, you can do your administration based on your terminology within your company. And when new people come into your company, you don't have to teach them these crazy host naming conventions. You can teach them, look, we have Puppet servers, or we have NAT servers, or we have shell servers. And they can take that knowledge and they can discover from themselves which are the machines that are Puppet servers or shell servers. And they can immediately become useful in doing administrative tasks against this vocabulary that exists within your company. So that's the basic ideas underlying it. Now, I'm not going to go massively into a demo here. I think, maybe you get the idea. If there's any questions, ask. I can maybe show a few things, but otherwise we'll go into discussing some more about Choria.
So with this, I basically can do status queries. I can do service restarts. Essentially everything that Puppet allows me to do, right?
Give me 1 second. So I mentioned earlier that it's quite introspectable about what you can and cannot do on your machine, or, what is available. So here I'm looking at the service agent, and I can see the available actions are restart, start, status, and stop. And it generates me documentation about what inputs I would need to give it, what outputs to expect, status, etc. And there's a whole huge amount of plugins here of what you can do. So here's a different one. It has a whole bunch of other actions, and so you may not know what the capabilities are on your network, but you can discover them and you can start exploring and dig in and look at the documentation available, and it will help you along the way. And I don't have it set up here, but I have tab completion. So if I were to do MCO press tab, I will get a list of all of the available agents. I then press service, I press tab, I can choose between start, stop, restart, status. And so it helps me along to construct these commands, which is quite handy. It is not one-for-one match up to Puppet. It may use Puppet libraries underneath, but you have to implement the agents yourself to deliver the kind of wrappings that you want. Let me have a quick show here. Now, there is the auto-generated interface, but people can also do things like generate custom interfaces. So here, for instance, it reached out to my entire network and it gathered a bunch of statistics about the most recent Puppet run. And I can see that I have, maximum 200 resource managers on these machines, how long the Puppet runs takes. I mean, these are taking very long. Oh no, that's how long since, sorry. How long my run times are. So, and it shows me the distribution of where these nodes lie on this time frame. So this is a custom interface. This is not automatically generated. So you have a way to enrich the API with custom interfaces and custom UIs. And so I'm not entirely sure what that does anymore. Oh yeah, it gives you some summary. Yeah.
Cool.
Okay. So let's get this back up here. Here we go. So MCollective, as I mentioned, it's quite an old project. And I sold it to Puppet back in 2009, I think. And they've since kind of moved on from the project and they're not necessarily maintaining it anymore. And so what Choria is a project to continue maintenance of MCollective and to continue developing it forward. And so there's a number of issues with MCollective. It is, for instance, extremely extendable. Like you saw there was a bunch of plugins there, and there's 16 kinds of plugins, and you can replace the encryption on the wire, you can replace the authentication, the authorization, the auditing, you can augment it with your own policies. If you use some crazy security policy, I can almost guarantee you'll be able to plug it into MCollective. This extensibility comes at a price, which is installation price. And so if we look at the installation docs, it just never ends. It just goes on and on and on and on and on. I mean, these are just the headings, right? It just goes on forever. There is so much to do to install MCollective that I don't believe any sane person has ever managed to deploy a fully, proper, secure, authenticated, authorized, audited, TLS, everything ever in their lives. I don't think it's ever been done other than maybe by myself, because it is just not worth it. And you look at the middleware, it's a nightmare. So to fix that, I started a project called Choria, and that was my first goal, was to fix that problem, which is the installation problem, and to modernize MCollective for the 3 or 4 years where it hasn't had big active development. Now, Choria does a bunch of things. Ease of installation is top of the list. I have had people who have never touched MCollective in their lives, gone from nothing to what I would call production ready, this thing that I said no one has ever done, in 30 minutes. If you've touched MCollective before and you're not like reading every word in my documentation, people have done this in 10 minutes. And with that 10 minutes investment, they are able to manage 50,000 nodes out of the box. So that was the primary thing for me with Choria, to get that right. Because there's no point in having software that no one can deploy or that people give up halfway through. And so once I've gotten that right, well, in order to get there even, I had to redesign large parts of the internals of MCollective. Luckily, everything is plugins, and so and at the same time, I was able to modernize a bunch of stuff. So we now have modern PKI. MCollective's PKI was quite difficult to understand in the past, because if you imagine, SSL with a web server, you know who the web server is, right? You make a connection to it. You can create secure packets for the web server, and it's quite easy. Where if you don't know who you're communicating with, how do you do that? Now, if you think about your satellite TV broadcaster, they send an encrypted channel up to a satellite, and then they broadcast it across the entire planet or entire country, and somehow the encryption works. And so, MCollective of old, I modeled the security model around how that works, and it was fine and it worked, but it was difficult to explain. And someone with a traditional view over PKI, there was a couple of things there that would go, but why do you do this? This seems strange. It makes sense, but to convince them that it makes sense, you have to teach people need to understand a whole bunch of stuff about PKI. So it was difficult. Now I've gotten rid of all of that. It's now much more traditional, much more understandable. It still works, but it's much more traditional and understandable. Because it's quite old now, when I first started developing it, JSON wasn't quite so prolific, all over the place, prolific as it is now. So I used YAML over the wire, which in retrospect was an awful decision, both from a security perspective and just from a interoperability perspective. This is now all JSON. The connectivity is vastly improved. In the old days, you used to have to deploy, if you wanted to manage, say, 5,000 nodes, which 10 years ago, 5,000 nodes was a large amount of computers. Now it's not a lot of computers anymore. In fact, now for me, 10,000 would be less than my smallest addressable unit. So in the old days, to manage 10,000 servers, you would have had to deploy 6 probably physical servers for the middleware. It's insane. Now with Choria and with NATS, we can deploy one small 4 gig VM, and it will manage 50,000 nodes. And that's down to the improved connectivity. I've modernized auditing. It will give us structured information now. Every plugin lives on the normal Puppet Forge, along with every other Puppet module. So it's easy. And if you wish to extend MCollective in any way, you can package up your extensions also to live on the Forge with one command. It integrates very well with Puppet DB. Puppet just last month, or maybe even this year, it was last month, announced a new feature called Puppet Tasks. I'm integrating at all levels of that. It uses modern things like SRV records, and so you don't have to configure anything. You just start it up and it works. Out of the box, everything that I just showed you, package management, service management, Puppet management, all of that stuff, it comes, this is the basic install. Like what I showed you, all of those capabilities were day one features. You include 2 or 3 lines in your Puppet configuration and you're done, and that's what you get. And then I started looking at higher order features around playbooks and these kind of things, runbooks and that's quite popular within support organizations. And at all levels, all the way through, everything is about strong authentication, strong auditing, and strong authorization. The kind of things that enterprises need, and the kind of things that probably is an effort for startups. I'm hoping there's a good balance to strike, but MCollective focuses on those things. Any questions on those? If I went over anything too quickly, or you want me to expand on something there? Okay.
So far, no questions on the chat, so that seems to be good. If you would have to estimate, right, the amount of effort before to set it up, and now comparing it with Choria, would you say your attempted fix was successful?
Oh yeah, I mean, given that it now can take 10 minutes to achieve, it really, I mean, I know one or two people who have done it, but it was more like an academic exercise than production exercise. Everyone I know who runs old school MCollective, and this includes Puppet themselves when they distributed with Puppet Enterprise, everyone have taken shortcuts somewhere with the deployments. They either don't have the concept of separate users, and so how can you have RBAC if you don't have separate users? Or they don't encrypt the transport, or they turn off somewhere, because every step, every layer on top of it, because it's like an onion layer of ever things that build on top of each other, right? And everyone was choices you have to make. Which plugin do you choose? There were 4 different security systems to choose, and so you go through the installation process and it says pick a security model. Like, how can you pick a security model if you don't understand the software? And so what Choria has done, it hasn't taken away any of these extensibility points. It has made decisions that's going to work for most people. And so there's one choice of a security model, and that's what you install, and it's secure. I will get it audited properly by a third-party entity, but from history, I know that the model that Choria deploys is the best possible MCollective model, and it takes you 10 minutes. Like the AWS infrastructure that I just showed you the demo on, I actually forgot to start it up before the call, and I tapped Terraform deploy at 10 minutes before this call. And what you saw running there was fully deployed and working. What I would consider the perfect deployment of MCollective. So that was yeah, I'm super stoked of how that turned out.
Sounds cool.
So I'll talk a little bit about some, well, mainly the playbook feature, which is I won't show any playbooks because it really is it's a talk on its own, which I'm happy to give, but we would need to reschedule that because it's a large topic. But the basic problem is, and this is one that all of us have, and even my example here is oversimplified. We all have these kind of web stacks, and here, I don't know, I guess I'm serving static web pages because I don't have any database or anything here, but you can see how this is something that we all recognize. It's a load balancer with a bunch of servers behind it, be it web servers or app servers or API servers or something along these lines. Somewhere would be databases and so forth involved. And what we typically do for deployments, we don't do, oh, it's Thursday night, 2 o'clock, we take the site down anymore because the world has changed. So we need to do things like blue-green deployments. We need to take down half the cluster, and we need to be able to deploy, we need to be able to deploy, just parts of the stack at the half, and we need to do a bunch of tests. So if you think about what you see on your screen here, and if you wish to deploy to, let's say, the alpha cluster, there's a large amount of steps you have to go through. And my speaker notes isn't showing up, so I'm going to add a little bit, but let's see. First of all, we have to find out what is the load balancer, because maybe I have multiple load balancers, and my application, this is a specific web application, where I may have, I might run 3 or 4 or 5 different stacks, and I may have 3 or 4 or 5 different HA proxy clusters. So first of all, I need to find out which is the HA proxy cluster for this specific app stack. I then have to find out which are the nodes that makes up the alpha cluster of this app stack, because I don't want to take the entire site down. I then want to be sure that I can actually administer these machines. They should all be up, and they should all be operable to the point where, via my administration tools, I can kick them off. And I should also be sure that the automation tools that was deployed to those nodes match my expectations. So if I have a script that upgrades a web app and there's a bug in the script, I must know that I will never run the buggy version of my script after I fix it. And so you need to audit your machines to make sure you match those criteria. Maybe you're in a very strict environment where you have a release manager who has to set these machines that they are now in maintenance mode or not. And MCollective allows you to express this as part of RBAC. So you can say that sysadmin Bob is only allowed to upgrade this stack if the stack was set to maintenance mode by release manager Jill. That is the only way that you're allowed to make these calls. And so MCollective's RBAC allows you to express that. You then have to go and drain the traffic off the machines. So you have to probably speak to the HA proxy machines, take half of the stack out of HA proxy. You have to make sure the Puppet isn't running. You need to disable Puppet, because if Puppet is doing stuff in the middle of your deploy, it might undo some of your efforts if it doesn't understand this mid-upgrade state. So you have to stop Puppet. You have to wait for Puppet to stop on all of these machines. You then shut down your app tier. You do your upgrade. You start it up again. Now, it might be a Java app, so it will take a while to start up. It will take a while to warm up its caches. So you have to keep checking it. Are all my machines' status is returning good? Is the web servers up? Am I ready to start serving customers? Once that happens, go back to the load balancer, or before I even go back to the load balancer, sorry, maybe I do a Puppet run because all my machines are back into a normal state, and Puppet will handle any kind of strange things that happened during this deploy. Once that's all done and these Puppet runs were successful, I go back to my load balancer and I put my machines back into the load balancer, and finally my stack is upgraded. But now what? Now I have to do things like notify the other administrators, maybe even before the deploy, during the deploy, after the deploy. And so my playbooks can integrate with Slack. Maybe I have other third-party systems like some kind of a webhook or some kind of a Jira or some kind of alerting or Graphite or something along these lines, which I wish to notify when I start and end a deployment, because you will see anomalies on those graphs. And so the playbook system supports integrating with all of these things I just mentioned. And it allows you to do all of these steps that I just mentioned. And it's two formats. Either it's a YAML format, which would be familiar to people who maybe use Ansible, or something like Rundex runbooks. Of course, every bloody YAML format is completely unique, so you'll have to learn how this one works, but you know, it's how it is. And this is kind of an emerging feature. Last month, Puppet released a feature called Puppet Plans, which is a way to write these kinds of logical flows within the Puppet DSL. And so the entire playbook feature and all of these integrations are available within Puppet Plans as well. For instance, for discovery, like I just mentioned that I built my infrastructure using Terraform. My playbook can discover against Terraform. So I can use those outputs that comes out of Terraform and say, which are my web stacks, which are my database machines, which are my load balancers, if that's what I wanted to do. Of course, there are loads of variables inside these playbooks, you know, which versions to deploy, passwords, all this kind of stuff. The playbooks integrate with console, with etcd, with Vault. Another super important thing that I don't really see in many of these kind of orchestration tools is, you can imagine if two people were to attempt this deploy at the same time, it would be a disaster. And so Choria playbooks allow you to have a network-wide lock in a tool called console, and you can lock around these critical steps of your playbooks that you only ever want to execute it by one person, no matter on which machine they run it, on any desktop, on any Bastion machine, on any administration server. You can put a lock around those things, an exclusive lock, so that at any given time, only one person will be able to execute this upgrade. That's and again, as I said, everything is underpinned with the authentication. The system knows who you are based on your security certificate signed by the Puppet CA. The system knows what you can do because there are RBAC roles written to match your certificate, and the system knows what you have done because every action is audited into JSON files or into Logstash or any of these kind of systems that you have. And every task is recorded, audited, authorized. It tries to strike the balance between, let's just write out these scripts and run them on our kit, but while maintaining some of the things that enterprises need: no access to boxes and full AAA stack. You can have a look at the Choria website. The link will be at the end of the presentation for more on the playbooks. And if anyone's interested, I'm happy to do further follow-up chats about that kind of stuff. But it's pretty powerful, and I'm really excited about the Puppet task stuff. It's a bit early for that. They haven't fully shipped yet, and they're kind of beta form. But once those things are released, it'll be very, very, very nice. Questions about the playbooks?
I think we're good on those.
Cool. So I'll just have a quick chat then about roadmap, and then I'm pretty much done. So, as I said, MCollective is Puppet has not really been developing it forward on their own, and they've been kind of going towards a more happy kind of SSH to boxes approach, which doesn't really gel well with enterprise setups. Like where I work, we have hundreds of Bastion machines. We're not allowed to use SSH keys. We have YubiKeys, two-factor authentication. It's ridiculous. I can never SSH into machines. It takes me a minute per machine. So those kind of approaches will never work. But we do have hundreds of thousands of MCollective boxes because the networking and the auditing and the security is designed to work in those scenarios. But the Puppet task is quite a nice, easy to write, very accessible little container for logic. And so I'm taking those little things and I'm integrating them tightly into MCollective's world to give a kind of a more robust execution model around those things for the open source world. And as I mentioned during the playbook stuff, Puppet Plans is this little script like DSL for Puppet. Deeper integration with Puppet Plans and the playbooks. Puppet Plans will ship, I think, like production ready probably in 2 or 3 releases of Puppet, and so obviously I have to just wait and see how those turn out. What they have now works, but it's a bit of a pain to get going, so I'm not ready to really say that's a done deal yet until they finish their work. I mentioned things like 50,000 nodes and 100,000 nodes. I mean, it's, these numbers from a vendor or from a project is always taken with a bit of a grain of salt. I say those things because I have actually run that, and I have developed an emulation suite that will, across, if you have 100 nodes, you could emulate 100,000 MCollective nodes with them, and they will make the exact same network traffic, the exact same network socket connections. They'll put the exact same network load on your infrastructure. And you'll be able to validate that for your networks and for your equipment and for your middleware and for your deployment scenarios, you'll be able to scale it to the approach you want. And you'll be able to do those validations independently of me. So when I say 50,000 nodes, you can validate that. 50,000 nodes you can validate with $5 of EC2 budget on your own, and I will be doing that validation at the end of every release, or before every release I should say, so that I ensure there's no regressions or anything like that. I am looking towards a single binary deployment of the entire thing, so you're not going to have to deploy additional middleware or additional routing software or additional this or additional that. It's going to be a single go binary that you put on your machine. Now, that out of necessity means we'll be replacing the Ruby daemon, which is there now, which is no big loss. I think takes hundreds of megs of memory, where the Go one takes 10 meg memory or something like that. And it's easier to deploy, it's easier for us to upgrade, And with that, I will have extension modes that vary between really fast, strong integrations that you can compile into the binary, extensions written in Lua, extensions written in Ruby, and these Puppet tasks. Now, this isn't just for deployment on servers. Obviously, I'm looking towards being able to run these things in IoT environments and this kind of stuff. And that's why I'm really focusing on these really large numbers of managed nodes, because I want to be able to run, the stuff on Raspberry Pis. And so the new daemon is tailor-made for that stuff. Since I focus so much on security, I would want to be FIPS compliant. It's a bit of a struggle with Go, but I have a model that will work for that, and I've spoken to FIPS people, and they've approved of the design at least, and so it'll become FIPS compliant. Built into MCollective is registration, so you can build things like CMDB. I'm busy building a really large registration system on top of MCollective, and as part of that, we'll be revamping how registration works and federation works, and the documentation and the extensibility, and so will, of course, inevitably change, but also be improved with the Go and the single binary rewrite. You can find all the information about the stuff that I mentioned over there. Choria, MCollective is documented on papa.com. NAS is the middleware that I use, and you can find my blog on devco.net. I'll leave those up there, but the final slide is just how you can reach me if you have questions. I'm happy to do, calls if this has sparked anyone's interest, if their team wish to hear more or bounce questions off me, happy to have those calls. And Choria is a fully open source project. There's no commercial interest behind it or anything like that. I just enjoy doing it. So, happy to speak to anyone about the stuff.
I was just about to ask this from a licensing perspective. How community?
It's Apache 2. Both MCollective and Choria has Apache 2 license, and it will stay that way basically.
Okay.
Yeah.
Very cool. Thank you very, very much for presenting. If you have any questions, feel free to drop them now. Otherwise, I think you can always reach out on Twitter or via email, right?
Yeah.
Thank you very much. Great content today. And I'll look forward to posting that recording into our YouTube channel as well, because it'll fit quite nicely into our automation and API series.
Excellent. Thank you very much for your time.
Yeah, perfect.
And thanks for having me. Okay.
Oh, thank you very much for presenting. If you do want to do any other topics, like a further deep dive, etc., feel free to drop me an email.
If we hear questions about things like the playbooks, I will certainly get back to you. Yeah.
Perfect. Then.
Good. Thank you very much.
Yeah, I'll close the session for this evening. Tune in next week again. We'll have Sam McGowan presenting on NSX APIs. And with that, yeah, have a nice evening, everybody. Bye-bye.